In this video I covered the window wiper to include the window wiper assembly and the wiper controller. Before we continue, remember, if you find the material in this video too technical, please watch earlier videos where I cover basic electrical knowledge. Keep in mind that the first 28 videos are best understood if you follow their sequential order. Now, back to our video. This morning I'd like to talk about window wipers. We got a window wiper over here, obviously with the wiper, and so I'm going to show you the inside of the box. I'm going to show you where the controls come in. Also, we're going to talk about the window heaters that they are there. This is a controller for the actual window wipers, and I just demonstrate this one over here. I just got this one over here. I just turn it on, and the window wiper is associated with it. It's working. Some of them are tag out, so that's why some of them the one that I did a moment ago doesn't work. So over here I'm just changing the speed, and the window wiper just goes with it. Also, we got in here a heater switch, and this heater switch, well, the heater is on right now. It does not control these window heaters. Don't get it confused. These window heaters, they actually get controlled by their own controller. So as you can see, the switches will just turn on. So right now we just energize the window heaters. So there are a few more boxes that control them. So that is for the window heaters. Now this heater over here is just actually sometimes the mechanism on the binding arm itself, what makes it rotate in the internals, it needs to get heat up to break up any ice. That's what this heater is for. Inside of the controller, so we got 2 leads of power. System is tag out, so I can definitely stick my hands in there. And then this over here is what gives power to the heater, and now this, it goes to the DC motor, because it is a DC motor that energizes the system. We got a little schematic over here, and on the schematic, so I got my motor over there. So I'm trying to. So this is my motor, and connections 1 and 2 are, like I say, connections 1 and 2. The 1 and 2, you can see it right there, that it is 1, 2 through 5. That terminal board is this one over here. These are, so if you see this box over here that I'm kind of tracing with my finger, that is what is supposed to be inside this box. What is inside this box is that terminal board plus all of these components that are part of the controller. So we have motor protectors, we got switches, and let's look at some of those components. First, the rectifier. The rectifier is this little square. One side is this box over here, and it gives me positive, the other side negative, and then on the these other 2 corners is where the AC signal comes in. This is my variable inductor, and that's what this component is. To better explain how the power transformer works, I withdrew this diagram. So here I got the terminal board of the controller, and this is a push button over here. This is a system protector. It's like a breaker built in. Sometimes it goes bad. Make sure that it's always good, that it is shorted. Then after that it goes to motor protector. Interesting, the motor protector first, it sends power to the power stack. Then from the output of the rectifier, also power is got to go through the protector before it actually goes to the motor. The power stat, well, it gets one phase of power over here, and then another phase of power over here. And this selector switch, which is a 3-position switch, as you can see over here, sometimes it will be showing this point to that, as I'm doing on the cursor, or sometimes it will be off like it is right now, or it will be showing the center to the left, as I'm showing right now. So in that way, for part, we will be drawing power from number 4 of the power stop, and whenever we are in on, we are drawing power from test point number 3 on the power stat. So well, a rectifier is a rectifier, and to troubleshoot, one of the common problems that I find is that sometimes the switch goes bad, so you just gotta make sure that you have the proper continuity whenever you have the position either to the on or the park from the center. These motor protectors do go bad a lot too, so make sure that you check good continuity between those two test points.
On the schematic, now there is another box, and that is the actual assembly that contains the motor, and there is a heater. That's the wiper arm heating element. That's the one that I said it gets control from this button. I also have two switches. That's a set of switches, one and another switch over here. Those are this switch here and that switch there. These are motor protectors, and that's what those are. That's the motor protector.
So it could be something wrong.
That's gonna blow. This is one of the motors that it will be, that actually drives the wiper, and these are the two wires. It is a DC motor. DC motors are very powerful. It has a reduction gear inside of it, and then out of one of these pins, depending whether you are closer or farther away from the center, wherever you hook up the wiping arm, that means that it's either gonna go farther to the sides or stay closer to the center. Once you do that adjustment, it's fixed. Remember, one motor, the windows, some windows are bigger than the other ones. That's why you're gonna have to do the proper adjustment if you ever replace one of these units. That's what I eat mine. Alright. This is the part I was talking about, that whatever you decide to tighten it in, it's gonna affect how far this is gonna go out, or whether it's gonna stay in the center. For bigger windows, you wanna go farther away from the center. For smaller windows, you wanna go as close to the center as possible. And in here, we just got a simple, very terminal board. One is for the heater, and the other one is for the motor connections. And that's all it is in this side.
Just so it won't be like...
This wire that comes out here, it goes into this heater. This is the heater for the wiper arm / motor. One constant problem that I find is that this bolt over here gets loose, so sometimes the motor will work, but there will not be rotation in this side. So I just simply come in and tie this. Worst case scenario, what I had done is replace a longer screwdriver, a longer bolt, put a knot, and just tie it really, really good, so in that way it just clamps in perfectly. Do it, Gordillo. So this one is very loose over here, so we're gonna tie the knot so that it doesn't free spin. So go ahead and tighten it, please. Once we tie this knot, the motor spins fine, but it just simply, we do not have the arm moving. By tightening the knot that he is trying to tie right now, it will fix the problem. Regardless of all the instructions, we always find out that finger tight, that screw is the best option. Too tight of that screw, it will just make it difficult for the arm to rotate, causing the overloads to trip.
So that's good then, right?
Yeah, it should be.
So we've in the motor right there, and the motor reads 24 ohms. Yeah. So the motor is good, at least electrically. We found out that we need to replace the motor. The way how it was connected is actually had these bolts over here, which you go to each side over here, and that's how it was attached to the ship. I already did that part, and now I went ahead and I got it in this side over here. I also removed this little connector right there. So to replace the motor, we're just gonna have to go on the back of it. And this one I remove it so I can actually get to the screws over here so I can have the motor come off. So here I got the old motor. The old motor has an EMI filter, the new one doesn't. So I'm gonna make sure that this EMI filter is good, and if it's good, I'm gonna reuse it on this one.